Alright guys, so on this note, it's going to ask, what is a square root? Remember that in math, we use words here with intention. So when it says square root, that's going to be a clue to what we're looking at visually and otherwise. So a square root is also known as a radical symbol, so we're going to have this symbol here. But it says read as a square root. Now, the reason why the word square is there is because in this symbol, there's actually a little square here, which we call an index, that we don't write, this little 2. So you'll see this later, but there is a little 2 here that is implied when we have a square root. But for now, you just see it as a square root without the 2, but there's a little 2 there that is implied. So it says, finding the square roots of a number a is represented by plus or minus radical a, or square root of a. This is your textbook definition. So when I say the square roots of 16 are plus radical and minus radical, guys, that's going to be 4. So the square root of 16 is going to be 4. And of negative radical 16 is going to be negative 4. This is true because 4 squared equals to 16. But at the same time, negative 4 squared also equals to 16. So notice how in this case, the minus sign is outside of the radical. This is a grouping symbol like a parentheses. So this radical links this 16 by itself, and this negative is not part of it when I work it out. Now this still may not make that much sense. So let's actually look at this in a different lens by drawing a picture. So let's rechunk this. So why is it called a square root? Again, the operative word here is square. Let's draw a picture. Guys, to find the square root, think of it this way. A square root represents the side length of a square whose area is the number that we're looking to work with. So in other words, if I want to find the square roots of 16, think of a square with an area of 16. What would the side length be of that square if it was going to be 16? Remember that squares have 4 equal sides. So the square roots of 16 would be 4 and negative 4. Because 4 times 4, or a 4 by 4 figure, is going to be a square with sides of 4. Guys, in other words, if I look at this graph here, let's put this on a grid. So if I were to count out here a length of 4 on this x-axis, I get this segment here. From 0 to 4 would be here. Let me do that again, it's a little messy. So from 0 to 4 is going to be here. And if I go up the y-axis, here's another segment of 4. If I complete this figure, notice how I make a square. Well, this square has an area of 16, so the square root of 16 is going to be 4. That's what those things mean. Think of it as the root of this square. So this is a square root. So that's the visual representation of what that means. I can equally do it with negative 4. So if I actually go on the x and y axis to the negative side, here's a segment from negative 4, and go down the y-axis to get negative 4 also. But this too will give me a square with an area of 16, still being positive. So this is a visual representation of what a square root is. A square root is going to represent the side length of a square whose area represents the number that we're looking at. So for example, if I want to find the square roots of 49, I can consider a square with an area of 49. The square roots are going to be the side lengths of this square. So we know that it's going to equal to 7 times 7. So 7 is a square root of 49. But I can also equally look at this as the square root of 49 from the negative direction, which would be negative 7 and negative 7, because that still multiplies to make a positive 49. So in this case, the two different square roots of 49 will be 7 and negative 7. Now, for this example, guys, this should be a plus or minus. So here I get plus or minus 7. Now, with that being completed, let's go here to the side here with perfect squares. And again, this still may not be perfectly clear, but with practice, it'll make more sense. If I want to find perfect squares, here's my first 4. The square root of 1 is going to equal to 1. Guys, this is true because a square with area 1 has side lengths of 1 and 1. So 1 is a square root of 1. Next, the square root of 4. Guys, 4 is a square with area of 4. That's going to be a 2 by 2 square. So the square root of 4 is going to be 2. The square root of 4 is going to be 2. The square root of 9. What that means visually is I have a square with area 9. So a square with area 9 is going to be 3 by 3 square. So the square root of 9 is going to be 3. You guys follow? That's how that works. So again, square roots visually are the side length of a square with a given area. What's the square root of 16? Well, 16 is going to be a square that has sides of 4 by 4. So it's equal to 4. And guys, this list will go on, so we should memorize the first perfect squares. The square root of 25 will equal to 5, because it's a 5 by 5 square. The square root of 36 is 6. The square root of 49 is 7. The square root of 64 is 8. The square root, of 81 is 9. The square root of 100 is 10. The square root of 121 is 11. The square root of 144 is 12. And they go on and on. So guys, again, think of square roots visually as squares with given side lengths.